right, here's our day 3 on solving trig equations. Today we're going to look at angles other than just regular old x or 2x inside. What effect does that have on our solving? So if you take a look at this first one, I want you to see if you can figure out what's different about it than all of the other equations that we've solved. So degree of the function is 1. It's sine to the first power. And we have some variables and some numbers here. But what's different to me, what stands out the most, is the angle expression itself. Instead of just being x, there's something else added in there. Now, there are formulas definitely on our formula sheet that can address something like this, but if the situation is more complicated, what does this mean for our solving? What are we going to do? Well, because it's degree 1, when I look at the equation, it's degree 1, I'm going to think of this just like I would any other degree 1 equation. I'm just going to solve. I'm going to use opposite operations, and I'm just going to solve it for the value of that function. So I'm going to go ahead and divide both sides by 2, so that gets rid of that coefficient, and see if I can figure out what's happening when I look at this sentence. It says sine of an angle. I know the angle measurement's kind of a complicated thing to look at, but that's equal to square root of 3 over 2. So if this had just said sine of x equals square root of 3 over 2, I don't think anybody would really have an issue with that, because that would just mean, okay, well, at what angle is sine square root of 3 over 2? 60 degrees, done. Well, that expression, whatever's inside, still has to have that value. The only way sine can be square root of 3 over 2 is if I have a 60-degree reference angle, which means whatever inside, whatever that angle expression is, it still is going to have to be equal to 60 degrees. It's just that now instead of just being x in there, it's x plus 30. Well, okay, then I can figure out what value of x makes that true by just solving that expression for x. So if x were 30, well then yeah, when I plug 30 back in, 30 plus 30, that's going to give us that 60-degree value that we need, because we know sine of 60 is square root of 3 over 2. So I know that it's a little bit more complicated expression, but we know still what the value of that expression needs to be. You can solve for the value that makes it true then. So it's just a little bit more involved to think that extra step. Now I'm going to point you back to our domain here. Do we have everything covered that we need if our domain is 0 to 360? Is 60 degrees the only value where sine is positive square root of 3 over 2? Is quadrant 1 the only place we have to worry about? Well, no, we've also got quadrant 2. So in quadrant 2, I would say then that that expression for the variable, or for the angle, I should say, has to be equal to the 60-degree reference angle in quadrant 2, which would be 120 degrees. So that means x would also be 90. So we have two different places where that's going to occur because it's 0 to 360. Now, if it had been principal values, we would have only needed that first value in quadrant 1. If it were all values, each of these would have your plus 360k, because that would be showing that it's everything. So it just depends on what your domain is, what kinds of solutions are you looking for. So angles other than x, still solve. Just do your degree 1 solving, but then we can figure out what x has to be because we know what the value of those angles have to be. So we'll try one more of those. I want you to take a look at the angle measurement, or the angle expression in this one, 5x. There's nothing on your formula sheet like a 5x, so this is definitely different than the ones we've seen before, but it's still just sine, right? It's sine to the first power. It's a single variable, degree 1. We're just going to go ahead and solve. There's just one function in this equation, so solve for it. So divide both sides by 4. That would give us sine of 5x is equal to a half. Now, again, I can figure out what value that this expression has to take on by just thinking sine of what gives you 1/2, or inverse sine of a half. What value would that be? Well, when is sine a half? That happens at 30 degrees. That means 5x would have to be 30 degrees, or x equals 6. So we can actually work backwards and figure out what that value would have to be. Once again, let's go back to our domain. Is that the only place? That's quadrant 1. Where else would sine be a half? Well, in quadrant 2, so that would be where 5x is equal to 30-degree reference angle in quadrant 2 would be 150. So x would be equal to 30 degrees as well. So because our domain is 0 to 360, I do end up with two values that make that true. If this were principal values, I would only need the 1 in quadrant 1. And if it was all values, then it would be the plus 360k, so all the coterminals as well. So when you think about angles other than x, if it's a single variable like this, you can still just solve, and you just have to think about what value does that expression have to be. If it's just x, cool, then we know it's x equals that value. But if it's not, if it's more involved, just solve for that value of the variable that makes it true. And that wraps up our section on solving trig equations.